Okay, now we are going to continue factoring, but we are going to learn to factor a trinomial. And first I wanted to review two types of factoring that we have gone over already. And that first type was called factoring using the greatest common factor. So here I would look at these two terms. I would determine that their greatest common factor was 2w to the third. And I would then factor that out. So I would think backwards. I would think 2w to the third times what, or distributed to what, gets me back to here. And that would be 3 minus w squared. And then mentally, or maybe I actually would write it out on paper, I would distribute and see if I get right back to where I started. So 2w cubed times 3 would be 6w cubed. And 2w cubed times negative w squared would be negative 2w to the fifth. So then I know that I've got it correct, and I can move on. So the next type of factoring we looked at was called factoring by grouping. So it's where you can see here I have four terms, and they do not all four have a common factor. So then I could group them into groups that do have a common factor. So here you might notice already that these two groups do not have a common factor. So remember, I can rearrange them just as long as I don't actually change any values. So I can have my y squared plus 3y, then plus xy, then plus 3x. So I haven't actually changed anything. I changed the order they're written in. Okay, so I still have my y squared, my 3y, my xy, and my 3x. But now I can group them. So these two terms have a common factor, and that is y. So I can factor the y out. So I would get y times y plus 3. And I bring this plus sign down in the middle. And then I look at my second grouping here. And the second group have a common factor of x. So I can factor an x out. So I get x times y plus 3 when I factor x out. So then what happens here is I end up with y plus 3 and a y plus 3. And so I can write this in factored form. I take this y and this plus x, and I write y plus x together. And since they are both being distributed to y plus 3, I write the y plus 3 just once, and I distribute them together. And this is factored. This is factoring by grouping. So then the next thing I want to look at is not factoring. It's actually the reverse. I'm going to multiply two binomials. So this is a review from a previous chapter. And we have been talking about the FOIL method. And remember, FOIL is just an acronym. First, outer, inner, last. And it just reminds us to multiply all four terms. So first term times first term gives me x squared. When I multiply the outer terms, I get plus 7x. When I multiply the inner terms, I get minus 3x. When I multiply the last terms, I get minus 21. And then I need to combine like terms here in the center. So I get x squared plus 4x minus 21. So then what we're going to do today is we're going to go backwards. So we're going to start with this polynomial, the one in the purple box there, and you'll be asked to factor this. So you are going to start with this and then end up there by factoring. And so really what you're doing, it's like you're reverse foiling. So we'll begin. So for this first example right here, and for every example, the first thing you always want to do is check for a common factor. So I look at these three terms, no common factor. I know grouping isn't necessarily a good option here either because I just have these three terms. So what I'm going to do is I'm going to see if I could unfoil, which is factoring. So when you think about FOIL, if I were to multiply the first term times the first term, I think about what could possibly give me x squared. And there is only one possible option, that is x times x. X times x is x squared. So then I know a number here and a number here. And I want these two numbers when I distribute to give me positive. And so I know it's either a positive times a positive, or I know it could be a negative number times a negative number. However, this middle term being positive tells me it must be a positive times a positive. So then what I'm going to do is I'm going to go over here kind of off to the side, and I'm going to think about the number 18. I'm going to think about all the possible things I can multiply to get the number 18. I could have 1 times 18. I could have 2 times 9. I could have 3 times 6. And so I look at all these things I can multiply. I could get the product of 18. But I know when I do my outer terms, then I do the inner terms, I want it to combine to get 11x. So then I look and I say, which one of these would combine to give me 11? They all have a product of 18, but 2 and 9 would combine to give 11. So I know that these two blanks here are going to be x plus 2 and x plus 9. Now in this case, I could have written the 9 here and the 2 here because they're the same. They're both just x. And so if I were to foil this first, outer, inner, last, I get right back to where I started. So this right here is called factored form. So if we look at this second example, I check these 3 terms. There's no common factor. So I'm going to try to unfoil again. So whenever I multiply my first, remember the first, outer, inner, last, my first term times my first term, I want to get m squared, so the only possible option is m times m. I can see every single term here is positive, so I know it's going to be a positive times a positive. Then off to the side, I think about everything that would give me 14 when I multiply. So all these factors with a product of 14. So I could have 1 times 14 or 2 times 7. So for example, now this is wrong, but if I put a 1 here and a 14 here, I would get m squared, I would get plus 14. But when I do the outside terms and the inside terms, I get 14m plus 1m, not 9m. So what I'm doing here, off to the side, or maybe just mentally, is I'm thinking about what combine to give me the middle term, the 9m, the 9, so that would be 2 and 7. So that is the factored form, and if I were to FOIL, if I were to multiply these two binomials, I would get right back to where I started. Okay, a couple more examples here. So again, you always want to check for a common factor first. Here I do not have one. So I try to write this as a product of binomials. I'm unfoiling here. So I know y times y is the only thing that would get y squared. And I want my constant times my constant to give me a positive 8. So I know it's either a positive times a positive or a negative times a negative. This right here tells me it has to be a negative times a negative. So if you weren't sure how I knew that, it gets easier with practice, but I'm also going to explain that a little further. So here off to the side, I'm going to think about everything I can multiply here and here to give me positive 8. So I could have 8 times 1, or I could have negative 8 times negative 1. Both of those have a product of 8. I could do 2 times 4, or I could do negative 2 times negative 4. And so all of these have a product of 8. So when I distribute it here and here, I get the 8. But I want to combine like terms to get negative 6, or negative 6y. So I know it has to be the minus 2 and the minus 4 because they combine to give me the negative 6. So this is your answer. And something I always get asked is if they could write this way. And the answer is yes, yes you can. That is also correct. Since the y was just a 1y and a 1y, they are not unique, so you could write it that way. Okay, just a couple more examples. So here again, I'm checking for a common factor. I don't have one, so I will try to write a product of binomials. I know the only thing I can multiply to get w squared is w times w. And since this number is a negative, the only way to get a negative is a positive times a negative. So I could have also wrote minus then my plus, that's okay. So then over here off to the side, I'm going to think about everything I can multiply to get negative 15. So I could do negative 15 times 1. I could do 15 times negative 1. I could do negative 5 times 3. Or I could do 5 times negative 3. So all of those would give me that product of negative 15. But when I'm foiling, I want my outer terms and my inner term to combine to give me positive 2. So 5 minus 3, that would give me the positive 2. So I know my plus is with the 5, the minus is with the 3. So that is my answer. And remember, if you wrote w minus 3, then w plus 5, that is also correct. So we will do one last example here. So notice this example has a leading coefficient of 2. So typically that means we have to go about factoring a different way or think about it differently. But so far in every example I have said to first check for a common factor, and if you look, you do have a common factor. 2 is a common factor in all 3 of those. So I can actually factor the 2 out as the greatest common factor of those 3 terms. Then once I factor that 2 out, this part here in parentheses can be written as a product of binomials. So the 2, I need to rewrite it so that I don't forget about it. And now I'm going to focus on factoring the underlying trinomial. So I think about what I can multiply to get x squared. There's only one option, x times x. That's negative, so it's either a positive times a negative or negative times a positive, and it doesn't actually matter since those both say x. They're the same, so it doesn't matter. Then I would think what I can multiply to get negative 21. So maybe negative 21 times 1 or 21 times negative 1. Negative 7 times 3 or 7 times negative 3. They all have a product of negative 21. I want them to combine like terms to give me positive 4. So I know the plus is with the 7, the minus is with the 3. So this is going to be my answer. Don't forget the 2, so when you're doing your homework. And that's it.